So to kind of illustrate this, I've put 2 points on the board. I've put a point here, A, and a point here, B. Now, how many different ways do you think are there of getting from point A to point B? How many? Okay.
From A to B one, no?
One way? Thousands? Millions? There's an infinite number of ways of getting from point A to point B. For example, I could go out here, loop myself around, and then come back to here. That would be totally fine. Okay. Equally, I could go from down here, could loop around, go over here, go to Australia, come back again, and then come back to B as well. Right? It is a vector. It's a movement from one point to another. Yeah? So, yeah, stay there for a week and then come back again. But are you happy that in each of those paths, I am getting from A to B? I don't care about how I'm getting there. All I care about is that I'm getting from A to point B. Okay? Now, just because this diagram is going to get quite messy if I draw all the different possible paths on, for convenience, I'm just going to think of a vector as just a straight line from one point to another. Okay, so just keep it straight, keep it simple. So in fact, I'm going to rub all of those off. But as long as you're aware that it doesn't matter how I get from point A to point B, all that matters is that I get from point A to point B. Okay? Now, how can I talk about this vector? Well, I could write this vector like this. Okay, so this vector here could be described as, in fact, I'm going to do it in green to keep it consistent. I could say, well, this is a vector moving from point A to point B, so this could be described as the vector A to B with an arrow over the top. Okay, so going from A to point B with an arrow over the top. You notice this would not be the same as that. What does that thing say? Yeah, it's going in the opposite direction, right? So this isn't the same. This isn't the same. It's got to be the directions associated. And we always put the left-hand side one from where we're starting, and the right-hand side one is where we're going. Okay? Now, I don't even have to write this if I don't want to. I could actually give this a name, and we just call this a letter. So this could be like vector P. Now, if you look in the books, P might just be a bold-faced font. Okay? Now, clearly, I can't write it in bold-faced font, so all I'm just going to do is underline it. Okay? So that's an equally valid way. If you don't underline it, it's not a vector. Okay? So you must underline it if you're writing as a vector. You are allowed as well to write it like this. So with a line over the top. Line over the top. Now, how else can I deal with this vector? Well, I could think about this. Just remember, I'm moving from one point to another. I could break this down into its components. So its components will be a movement across and a movement up. Okay, so a movement left and right and a movement up and down. So it might be, for example, that I take 3 steps to the right and 4 steps up. Okay, those would be its components. If I wanted to write that in terms of this, I might write it like this. Okay, you happy with that? Now what this corresponds to is this top number corresponds to how far left and right I'm moving. So the fact it's positive, I'm moving to the right. If it was negative, I'd be moving to the left. Okay, so this is the left and right direction. Okay, the bottom number, what does that bottom number correspond to? Yeah, excellent. Up and down, right? Okay, what happens if I put a third number in here? So it's not applicable in this case. If I put like a 7 there, what would that correspond to? Not diagonal. So just think, so the top number corresponds to left and right position. The bottom number corresponds to up and down. If I wrote something like this down, so 3, 4, and let's say a 7, what would that number there correspond to?
The length is the shape.
Yeah.
I don't know how to width.
Okay, so have a think. So up and down, sorry, left and right, up and down. What does a 7 correspond to?
It's still like XYZ.
So what's Z?
Largura, altura,
Like
comprimento.
by yourself.
Exactly, it's like coming out of the board, wouldn't it? So it'd be like 3 to the right, 4 up, and then 7 out of the board. So it would like go something like this, okay? Now obviously in the concept of like, I can only draw things on a 2-dimensional board, so I'm going to stick with 2 dimensions for the time being, but as long as you're aware, that third number corresponds to forwards and backwards. Is that okay? So from a geometric point of view, we can only have 3 numbers, a maximum of 3 numbers, okay? If we stick a 4th one in there, like we're in the 4th dimension, Like, what's that all about, right? But yeah, so this is the kind of idea of what a vector is. In fact, this, if I rub that off for just a second, this 3, 4 looks very familiar to something we've seen before, right? If I wrote this down, that would be a coordinate, right? Which means move 3 steps to the right and 4 steps up. What's the difference between that and that? Okay, so this is representing a point. That's good. So a coordinate or a point.
There's not a vector because you're not going somewhere.
Say that again. It's not a vector because we're not going somewhere.
Yeah, you don't have the movement.
Do we not? If I ask you to graph this, okay, 3, 4 would be like something there, right?
Oh, this forms a triangle?
Well, I mean, we can form a triangle from this, I guess, because it'd be like that and that. So what's the difference between that and that? Why have I written it differently? Like this is just written as a row, this is written as a column.
Only one.
Because you're going from point A to point B.
Good, okay, so it's along the right lines. 3, 4 is moving from one point to another. This is moving from a point, but which point?
0, 0.
Good, it's moving from the origin, right? So a coordinate is movement from an origin, it's fixed, okay? Whereas with a vector, the most powerful thing about a vector is it can happen anywhere in free space. So it can be like anywhere you like. It's just 3 steps to the right and 4 steps up. Is that okay? Yeah? Good, so think of it like a coordinate in the sense you're moving left and right and up and down. You won't go far wrong. But just remember, a coordinate is fixed. It's movement from the origin. Whereas with a vector, it's moving from anywhere you like, any 2 points in space. It's just describing a movement. Okay? Okay, good. There is one other way that we can talk about vectors. And it's like this. So if I have the vector 3, 4, I could also write this like this. So 3i plus 4j. Now what's that all about? Has anybody seen that notation before, by the way? Yeah? What's that all about? Like, why are we suddenly introducing i's and j's? Who anybody's seen this before can describe what I and j means? Yeah, good. So it's along the right line. So basically, would you be happy that 3 means move 3 steps to the right? And 4 means move 4 steps up. Well, what if, instead of calling it steps, we just say that I represents 1 step? Okay, so we're moving 3 lots of 1 step, in this case, to the right. Okay, so I would be what's known as a unit vector. It's basically moving 1 step to the right and 0 steps up. In fact, if I was going to plot this on a coordinate grid, I would just be 1 step to the right. So just be movement from here to here. That would be I. Okay, 1 step to the right. So in which case then, what do you think j will be? Can you give me the unit vector for j? Excellent. So j will be 0, 1, right? It's moving no steps to the left and right and 1 step up. So j will be a movement from here to here. Okay, 1 step up. If I wanted to talk about the 3rd dimension, how could I do that? Like I've used I, j, what comes next? K. So k would be, if I'm talking about 3-dimensional vectors now, what would k be? Excellent. 0, 0, 1. Means no steps to the left and right, no steps up and down, and 1 step out. Just to keep it consistent then, because I'm now talking about 3-dimensional vectors, I'm going to change these to 3-dimensional vectors as well. Is that okay? Is that okay? You say k would be like 1 step forwards. Yeah? K would be 1 step forwards. Are there any questions about that? So the different notations that we can have. So you can either write it as A to B, moving from point A to point B. You can either give it a name, so call it P with a line underneath or P with an arrow over the top. Or if you want to talk about it in a little bit more detail, you can talk about it in a movement left and right, and a movement up and down, and a movement forwards and backwards if you wish, if appropriate. And this is exactly the same thing as this. It's just saying, right, I is just 1 step to the right. Okay, so I is 1 step to the right. 1 step to the right. And J is just one step up. Is that okay? Yeah? Any questions about that?